Welcome back to the channel. So today we are going to attend question number 6 and question number 7 and so on of miscellaneous exercise of chapter Relations and Functions, class 11th CBSE Mathematics. So this is question number 6. It states that let f is equal to x comma x squared over 1 plus x squared such that x belongs to real numbers. Be a function from R into R. Determine the range of f. So this is question number 6. The given function is f is equal to x comma x squared over 1 plus x squared such that x belongs to real numbers. Now in order to find range of this function, let us plug in the values of x and see what the output will be. Take for example, if x equals 2, we'll be having x squared by 1 plus x squared equal to 4 over 1 plus 4. That will be equal to 4 over 5. And this will be equal to 0.8. Similarly, for x equal to 1, we'll be having 1 over 1 plus 1. That will be equal to 1 by 2. And that's equal to 0.5. Now for x equal to 0, we'll be having 0 over 1 plus 0. That will be equal to 0 over 1. And this will be equal to 0. Now for x equal to negative 1, we'll be having 1 over 1 plus 1. And this will be equal to 1 over 2. And that's equal to 0.5. And for x equal to negative 2, we'll be having 4 over 1 plus 4. And that will be equal to 4 over 5 again. And this will become equal to 0.8. So your range is positive. And it lies between 0 and 1. So therefore, range of this function will be 0 to 1. With 0 included, but 1 not included, as the range lies between 0 and 1 with 0 included. Towards question number 7. Question number 7 states, let fg from R to R be defined respectively by f of x equal to x plus 1, g of x equals to 2 times x minus 3. Find f plus g, f minus g, and f over g. So this is an easier one. Here we are given with f of x is equal to x plus 1 and g of x is equal to 2 times x minus 3. Now what will be f plus g? This will be equal to f of x plus g of x, and this will be equal to x plus 1 plus 2 times x minus 3. This will be equal to x plus 1 plus 2x minus 3, and that will be equal to 3x minus 2. So this is our f plus g. Now what will be f minus g? This will be equal to f of x minus g of x, and that will be equal to x plus 1 minus 2 times x minus 3. That will be equal to x plus 1 minus 2 times x plus 3, and this will be equal to negative x plus 4. And finally, what will be f over g? This will be equal to f of x over g of x, and this will be equal to x plus 1 whole divided by 2 times x minus 3. Here x cannot be equal to 3 over 2 because this will provide the denominator equal to 0. Towards the next question. So question number 8 states, let f is equal to 1 comma 1, 2 comma 3, 0 comma negative 1, negative 1 comma negative 3 be a function from z to z defined by f of x is equal to a times x plus b for some integers a, b. Determine a, b. Z, as we know, is the set of integers. So this is question number 8. Here we are having f is equal to 1 comma 1, 2 comma 3, 0 comma negative 1, and negative 1 comma negative 3. So these are the elements. Now we'll be taking any two elements of this very function in order to determine the values of a and b. So let's see how this is done. So here the given function is f of x is equal to a times x plus b. We know what f of x is. F of x is nothing but y. So here we'll be having y is equal to a times x plus b. Now let us consider these two elements, the first one and the second one. So in first element we are having value of x equal to 1 and value of y is equal to 1. Therefore y is equal to ax plus b. That implies 1 is equal to a plus b, or we can say a plus b is equal to 1. Now for second element we are having x is equal to 2 and y is equal to 3. Therefore, y is equal to a times x plus b implies that 3 is equal to 2 times a plus b, or we can say 2 times a plus b is equal to 3. Now let us suppose this is our first equation and this is our second equation. On subtracting equation second from equation first, we'll be having a plus b is equal to 1, 2 times a plus b is equal to 3. This here will become negative, this one will also become negative, and this as well will become negative. Now cancelling out positive b and negative b, will be having a minus 2a is negative a and 1 minus 3 is negative 2, which means a is equal to 2. So this is the value of a. Now if we'll put the value of a in equation first, we'll be having 2 plus b is equal to 1. That implies b is equal to 1 minus 2, and that implies b is equal to negative 1. So therefore, value of a is 2 and value of b is negative 1. And the function which is f of x equal to a times x plus b will become 2 times x minus 1. Towards the next question. Let R be a relation from n to n defined by R is equal to a comma b such that a, b belong to natural numbers and a is equal to b squared. Are the following true? Part number first, a comma a belongs to R for all a belongs to natural numbers. So this is question number 9. Here the given relation is a comma b such that a and b belong to natural numbers and a is equal to b squared. Now in part number first, we have a comma a belong to real numbers for all a belong to natural numbers. So this one is false because a is equal to a squared is true only for a is equal to 1, not for other natural numbers. But it's given that a belongs to natural numbers, hence it is not a relation. Part number second, a comma b belong to real numbers implies that b comma a belong to real numbers. So this is part number second. Here we have a comma b belong to real numbers implies b comma a also belong to real numbers. This again is false because if a is equal to b squared, then b is equal to a squared is not true. Take for example, 4 is equal to 2 square, then 2 is equal to 4 square is not true. Hence it's not a relation. Towards part number third, a comma b belong to real numbers, b comma c belong to real numbers implies that a comma c belong to real numbers. So this is part number 3. A comma b belong to real numbers, b comma c belong to real numbers implies that a comma c also belong to real numbers. So this again is false because a is equal to b square and b is equal to c squared implies that a is equal to c squared whole squared is equal to c to the power 4, which implies that a is not equal to c squared. Hence, it is not a relation. Hope this makes sense. Do subscribe to the channel for more such content, and thanks for watching.